Our third area formula is for a triangle. This is another one that many of you guys probably remember or have used before. But let's just take a look at it again to see where it's coming from, because I still will see people make mistakes on the triangle formula. They'll use, say, the rectangle formula instead of the triangle formula. So the investigation says trace the triangle to the right on a sheet of patty paper, label the height h and the base b. Trace another triangle from step 1 onto the patty paper to form a quadrilateral. Hint, rotate paper 180 degrees. What type of quadrilateral did you make? What is the formula for the area of the quadrilateral? What should the formula be for the triangle? So if we take and make a second congruent triangle, and maybe take that and rotate it around, and then just like before, kind of fit it together like a jigsaw right here, and maybe just a little bit more rotation would be better. We can see that we now have a parallelogram. And that parallelogram is made up of two of the triangles. So what type of quadrilateral did you make? Parallelogram. What is the formula for the area of that quadrilateral? Well, a parallelogram, we know, is equal to base times height. So what should the formula for a triangle be? Well, there are two triangles that make up this parallelogram. 1, 2. But those two triangles have the same base and the same height as the parallelogram. So if there are two triangles that make up the parallelogram, then one of the triangles, therefore, would be half of the parallelogram. So the area formula for a triangle is simply half of the area formula for a parallelogram. Now I sometimes like to use base times height divided by 2 to represent that. Or you certainly can use area is equal to 1/2 times base times height, 1/2 BH. But base times height divided by 2 sometimes is a little bit easier, since for whatever reason we think that problems that don't have fractions in them are easier. So if we have divided by 2, sometimes that makes it a little easier to take a look at. Investigation 2 is then for a trapezoid. It says trace the trapezoid to the right onto a sheet of patty paper, label the bases and the height. So a trapezoid has two different bases. The parallel sides are called the bases of the trapezoid. So we got base sub 1 and base sub 2, and then the height between them right here would be the perpendicular distance between the two bases. Step 2, copy another trapezoid to the first one and create another type of quadrilateral. Hint, rotate patty paper 180 degrees. So we are going to do something similar to, as we did on the last one. We're going to take that and we're going to rotate that 180 degrees and then fit it together kind of like jigsaw. And again, we keep coming back to that same shape. What type of quadrilateral did we create? Well, once again, we have a parallelogram. Now, notice that this parallelogram, though, does not have the same base length as the trapezoid. But if we take a look at where these lengths are coming from, this length right here is the same as base 1 of the original trapezoid. And this length right here, is the same as base 2 of the original trapezoid right here. The height is exactly the same on both, so the height actually doesn't change. But we know that the area of any parallelogram is base times height divided by 2. Well, not base times height divided by 2. Thinking about my triangle in the last problem. Base times height. So the base of this parallelogram is made up of base 1 and base 2 of the original trapezoid. And the height of the parallelogram is the same. So the trapezoid that we're interested in is half of that parallelogram. So if we take the parallelogram, that area is base 1 plus base 2 times the height. So area is equal Remember, that's the area of the parallelogram, because base 1 plus base 2 is just the entire length of the base of that parallelogram. V1 and V2 are the bases of the trapezoid, but putting them together, we get the entire length of the base of the parallelogram. Times height, okay, so that's the parallelogram area, but our trapezoid is exactly half of that. So we'll divide that by 2, and now we have the formula for the area of a trapezoid.